And now I would like to hand over to Stephan and David to speak more about tools.
Yeah, thank you, Daniel. Thank you, Jörg, for the introduction of the project. So also welcome from our side. My name is Stephan Fox. I'm a mechanical engineer at the feasibility lab of ETH, and together with David Meyer, computer scientist, engineer, and software architect at NEXUS, we will present the way and the process that it took to get these machines that you've seen shown by Jörg into the halls of ETH and what challenges we were facing within this setup. Now, in the beginning, at the very early beginning, we were asked by Jörg is how can we automate dispensing of test kits and also the collection of test kits. And we wanted to start with a hackathon. So we invited a lot of engineers and engineering students to work for 2 days straight on such a project. And you can see here the poster that we made for the invitation of the CoVMass hackathon. And we also defined the 2 functions. Number 1 is the machine needs to receive an online appointment. It needs to scan the Legi and then needs to dispense the kit. And function number 2, it's a different setup, which was really nice to be able to divide those systems, is to scan the Legi, then scan the barcode on the kit, receive the test kit, store it securely, send information to the lab, and then be picked up by the laboratory for aliquotation. And the most important part in the beginning was really the close collaboration to define the interfaces with the IT and also with the aliquotation down the line. And the hackathon was a really fun experience and also strong, hard experience. We worked on prototyping in CAD. We have programmed electronics. We made a big mess, both in the laboratory and also in the workshops. But it was also a lot of fun for the participants, which is very important to get them for another hackathon again. And most importantly, we came up with 2 great prototypes for both dispensing and collecting. For the dispensing, we built, or we proposed a solution where we actuate a rotating system to hand out the vials individually. But what was really interesting in our prototype was that it was quite difficult to make sure that they don't jam the system. And also we noticed that the dispensing has already been solved by vending machines, click. So this was our prototype that we've built and noticed that there were quite some difficulties. And then we noticed, and then we got Selector on board with the vending machines. And we were super happy that they helped, that they provided us the system. And you can see in the next picture how we set it up. But then the challenge changed from building a system from the ground up to controlling and integrating the system into the IT network. And so together with Dave, we sat down and we had to emulate the number pad to send the signal to the machine. You can see on the right side these 10 pins that were our input, and we had to sit there, measure, press buttons, measure which pin is activated to find out what the signal is for the machine. And then we were able to build the lower relays that allowed us to actuate the system. And so by hacking this machine, we were able to provide the solution that you will see in the video. So it was pretty straightforward, which was a real success for us, and we were quite happy about it. But on the challenges, Dave will talk a little bit more in a later stage. Now, on the collector side, we had to solve an unsolved problem. So there was no system or machine that was available that collects these samples and then stores them in a way that you can transfer them to the aliquotation, where Christian will talk more about it in a later presentation. And so we had to build the system from the ground up. And to allow, or to build a system from the ground up that can reliably work in a critical setting where we cannot afford to have lots of jams or failures, we went with a system where you have these racks that you see in the sketch that take these samples and they fit into the aliquotation machine. And in the video that you will see now, there is the process on how to dispose these or give these tubes to the into the rack, and you see there's a layer beyond where they drop through, which allows to, or which avoids people getting in contact with other probes, and also being able to take out other probes is not possible anymore. So the basic function was found in this hackathon, and then we had to iterate until we were ready to provide it. So the first prototype that you've seen, that you see, is made from wood, which is this great material to prototype, but of course it's not feasible in an infectious environment. So we had to build another one from wipeable materials, and then we tested this one together quite some times with different use cases. And so with small improvement for the next one, we were able to have the system up and running for the tests. Now I've brought one last challenge, which was the racks. I think it's quite interesting. The ones that you see now that I use now are made from laser cutting. And these are laser cut and they are welded together like Legos assembled. And they were very quickly designed within a day, but it took quite some time to make them. And so we also in parallel worked on a new fabrication system, which you can see in the video. It's vacuum forming, where you heat a piece of plastic until it's soft, and then with a vacuum we can form it into the shape that we need it. And so in the end we will have these racks that you see here, which are a lot lighter and a lot quicker to build. It's roughly 5 times quicker to build them. So if we need lots of those, it works quite well. And with this, I hand over to Dave.
Yes, thank you, Stephan, for this nice introduction. You in this machine building department have always a lot of cool things to show. I try also to show you some impressions of our building processes during the software process. So I will focus my presentation on the software for the machines. There is also a back-end software with the database and for the registering process, but the focus for this presentation is really for the machine software. So what we did, or how we went through this process, was we exchanged the ideas before the hackathon that we have before we really start, and that was very important step. Because then we chose the controller to be a Raspberry Pi, so really a computer, a small computer with a 7-inch display to also display the user or guide the users through the processes on the machines. And then after the hackathon, I took over the motor control software parts from these engineers. And then with the ideas from the hackathon and also from the other team members, I developed the state diagrams for the machine controller and also designed the screens to guide the user through the processes. We also developed the backend API so that we can communicate with the machines to the database when the user drop off, pick up a while, drop off the while, and keep track of this samples to know, oh, this sample is for this particular user, to in the end then inform the user for the test results. And then we get together to install this first initial software and try the first run, and then the improvement phase or phases, because this is an iterative process, begun. The screens itself, I as a software developer just defined the screens, so how many screens are required for the processes, and then a professional designer helped us to design the screens and also the texts, because we have only this 7-inch screen, so we needed to decide what is the correct font size so that you can read the texts, and also how can we shorten the text that they do not overwhelm the screen, but also they are nice enough so that you don't think what I'm doing wrong here. And then also there were discussions about how many steps we really need, and shouldn't there be an intermediate step, and so on. So this was an iterative development and improvement for that. And one of the most difficult problems, let's say, something that came up in the beginning was, how can we prove that the vial was returned? And we discussed about sensors that we can recognize that the vial was dropped into the collector. But this was too complicated, and we ended up to just say, okay, the user can scan his ETH card again when he dropped off the vial. The methodology we used for developing these things was an agile one. So we really went through this plan, do, check, act cycle multiple times to get the things together from the machine construction and from the software development. The challenges there were really to find a good point to synchronize the work, because I needed to be at the stage where I have software parts available, and the machine construction unit needs to have the machines ready to go. And also a second challenge was to have all the third parties that were also needed to integrate the machines into the network, and also the facility management that provided us the materials that we needed to integrate them into the network, to have the tables where they should be, and so on. So this was from time to time a little bit challenging, but we managed that. Here I would like to show you some examples of the challenges that we had to gather with, and how we solved them. So one thing was how to empty the selector machine, because you need to refill it, right? And in the beginning, after a refill, we started to eject the test kits from position 1 on. This led to old test kits in the let's say in the last positions, and then we changed this algorithm to empty the selector machine from the beginning position to the last position, even if it's refilled in between, because we need to make the bookkeeping inside the software, because the selector machine is kind of dump, so there is they can just rotate motors and nothing else. Then the second one, we always wanted to eject a kit, because they could be trapped in the selector machine. And therefore, we also implemented an algorithm that we say, okay, if no kit is ejected in between 10 seconds, then we just rotate the spiral there again. And if it's not dropped from this position, we try the next position and so on. So we always want to eject a kit. Then the third one is we needed to have remote control for the machines because in these times at least myself, was working in the home office, and during the test phase, I needed to do lots of changes and adoptions to the system. And we configured the machines with a fixed IP address so that it can be remote controlled from my home office. That was a very convenient way to update and debug the system. Then the challenge with the selector machine, how to control the selector machine with Raspberry Pi. We talked to selector people, and the first solution that came up on our sites and also from selector was, why not emulating the numeric pad? Because this can be done with relays very easily. And we needed to measure what wires were activated when you press what number, and then we figured that out. We built the hardware and also the software to then emulate this numeric pad. Then the next challenge, one of the challenges was how to handle the drop-off procedure interruptions. Because during the test phase, we saw how many ideas a user could have. So, I start a process, then the door went open, but then I don't want to drop off my vial and I go away. And then the collector stands there with an open door, and the next person who wants to drop off his vial stands before an open collector, right? And therefore we implemented some timeouts. So if nothing happens after some time, we go to the initial stage so that the next person can move on with the process of dropping off the vial. And we also had the problem how to test these motors in the machine construction lab. And then we introduced some maintenance barcodes so that you can just have a barcode to open the door 1, open door 2, and so on. So this was easier to test than for the machine constructors if their construction really works. So these are some stories I can tell about challenges. We had a lot more, and it was very a cool working together with Stephan, I need to say here, and lots of learnings from that. To conclude these things, and just to point out the most important learnings we took out from this project was in the field of the methodology. So that the early synchronization is very important, so that not the software development and the machine development goes into different directions. And also this frequent get-together to really put the things together during the development process was very helpful in this project. And also always these simple and pragmatic solutions that I think we both, Stephan and me, always wanted to go to, were very important and we're working in the end, I mean, and we're also fast. From the user experience point of view, it's worth to have a professional designer that designs screens and stuff, because then it's a better user experience for the end user. And also the ramp up phase or test phase was very important to see how users are really interacting with the system. And from the availability point of view, the machine must be constructed in an always on manner, and it must have a reset to initial state functionality. So either over these timeouts or with just power off, power on to get it into an initial state. And the remote control was also very important to really shorten the debugging and updating cycles. And the reliability, that's what I mentioned in our challenges. I mean, it's very important that the machine works as it should. And this was is in the end crystal clear what you need to implement, but you see it during the ramp up phase or during production phase. For example, that you always eject the test kit, and so that people do not need to scan 2 times or whatever their barcode, and also the interruption of the drop-off process by the users, that we have these timeouts and escape procedures to get the machine into the initial state for the next user. And I put this nice little image of this hot glue gun here, because this was our main helping tool when we constructed our machine, and when we needed to fix something, and it becomes our first add tool during this project, and therefore I needed to put a picture of that in here. So thank you for your attention. If you have questions, I think you can put it into the chat, and we will answer the question. And yeah, that's it from our side. Thank you for your attention.